that 4 students are currently working on. It's due tonight, and I want to do an example of it. I'm actually going to go a little bit longer here because it's I want to do it first of all the long way, and then I'm going to do it the short way, and it's going to make a long video. Plus, I'm sitting here in my kitchen, which is one of my favorite places to work, and my wife's in the background, so there'll be a little bit of background noise, and I'd rather work here than any place else. I hope that's okay. All right, so it's a substitution mechanism, and here's the title, which I won't get if I get this on a test. I won't get that, but I will get it here. And so I know it's a substitution, so I'm looking for a nucleophile and a leaving group. And I'm going to take a shot of this, go put it on a whiteboard. Okay, so if I know it's a substitution, so I need a leaving group and I gotta set my tablet up. I need a leaving group and a nucleophile. Settings, back up and restore, reset. So on YouTube, the previews are taken automatically, and so it's kind of funny. Sometimes that Wacom tablet will show up as my preview that has nothing to do with the video. All right, so again, I'm looking for a nucleophile, and I'm looking for a substrate with a leaving group on it. Too high in the screen. Looking for a substrate with a leaving group on it, and I've got a nucleophile. These are usually going to be pretty easy, I think, in this topic to find. Later, they're going to be a little more easy to miss because, right, ALEKS is going to give you a chance to do more sophisticated things. But what I'm expecting to happen is this is going to come here and do that, or the leaving group's going to leave first. Another possibility is the leaving group will leave first, and if the leaving group leaves first, then what we're going to have is in a second step, right, this comes in. All right, so which dictates what happens? Does the blue happen or the green happen? And I will say that if we have a good, strong nucleophile, that's going to tend toward the blue. You see that? It's got a minus on it. It's got lots of raging electrons. Okay, it's a good, strong nucleophile. And if we have a secondary carbon here, secondary halide, then it's going to give the possibility for SN1 because secondary works. If it's primary, it'll never go SN1. But the question is blue or green, and I actually recommend in the beginning you go to the explanation and look at the table that's given to you. So I'm going to do that now. Probably not. I'm just going to give me a new problem if I do that. Let's go ahead and do it. So let's go to the explanation. It's going to give me a table that's going to say if I have a secondary halide, it's going to favor SN2. But there are some exceptions. See below. And I do have a secondary halide. So let's look. If it's going to favor SN2, but it's slightly hindered, but it's still possible. And it sometimes makes stable carbocations. So that's why it's possible to go SN1. So I have a secondary halide. I know I do. So I'm going to come down here. And here's, if it's a strong nucleophile, it's going to go SN2. If it's a weak nucleophile, it's going to go SN1. And notice this is a light. I'm not sure if that's got anything to do with it, actually. Okay. All right, it's going to go SN2. But if it's a weak nucleophile, it's going to go SN1. Very cool. And you know what I'm going to do? Let's go put these things in my notes, because you've got a cell phone, right? You can screenshot this and have it next to you. Let's come here. There's one table. Here's the next table. I warned you this is going to be a little bit of a long video. Here's the next table. And here's the next one. I think this third one looks to be just sort of a summary of the other two. Okay, so we have a secondary halide. It's going to go SN2, but it can only be inverted. And if it's a weak nucleophile, it's going to favor SN1, and it's going to be both retained configuration and inverted configuration. That'll make more sense. Maybe it already makes sense to you. I don't know. Okay, so consequently, I'm going to come over here. Let's go back over to the screen. It was secondary. It was secondary, right? And so so we say see below. So we look down here, and it had a strong nucleophile, and so it's going to go SN2. All right. So let's go back over here. Which of these is SN2? The blue is SN2 because two things happen at once. And so consequently, let's go ahead and do it. It's going to be boom, 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 boom. Wait, boom. And this is in there, right? And this is going to come in there and kick it off. It's going to come from the back side. And so consequently, it's going to be on the opposite side. And that's the answer right there. Okay, so you see the mechanism and you see the answer. Now let's go down and look at the answer, and then I'll do another one. The answer is that. That's the major products. I'm going to leave off the bromide. I think I'm always going to get credit for it if I do that. Now watch the mechanism. It's going to be exactly what we said. That comes from the backside attack, and this happens at the same time. Since it happens at the same time, it's going to invert the configuration. So this is going to come from the backside. It's going to flip everything over. All right, let's try another. Okay, so now a weak nucleophile and a secondary. Let me go back to my screen. Remember, if I have a secondary halide, it's probably going to go SN2, but see below. And so if I have a weak nucleophile, it's actually going to go SN1. You see that? And so consequently, what's going to happen is, I'm going to go, yeah, we are going to get something here. No problem. And let's draw the products of that. The products are going to be both. This is chiral, so it's going to be both. We're going to invert our configuration and retain it. It's going to be a racemic mixture. So let's go down here and say major products. All right, all that stuff is on there. It's just Alex giving you a chance to get your eyes used to it, okay? Let's come here, and it's going to be an oxygen because it's that oxygen's going to be coming in. And it's going to be that. And also that. All right, those are the major products. I'm going to leave the chloride out of it. You'll see we'll still get credit for it because we're really concerned about the organic products. Those are the major products. Now it's asking for the mechanism. Okay, so here's how the mechanism goes. I'm going to make this a little bit smaller. Here's how the mechanism goes. Add, bump, add step. Let's come here. Okay, so what's going to happen is these, if it's SN1, this leaving group's going to leave first. So it's going to leave me a carbocation in its wake behind. Okay, let's come here and go boom. Oh, I don't want that. Nope, nope, nope. Undo. Undo. Okay. Okay, now what's going to happen is these electrons here are going to come. If ever you're not sure if you want the electrons on there or not, just go ahead and put them on there. ALEKS sometimes requires you to have them there if they're an important part of the story. If they're not an important part of the story, then I think ALEKS generally is going to give you some leeway. Now, after that goes up there, then I'm going to have, boom. Now I'm going to have, I don't want that. Oxygen's going to be there. And it's going to have a hydrogen on it, right? Because I had a hydrogen coming in. Now that's going to be gone. That's going to be gone because it got satisfied with that. Boom. And boom. Right? That's what happens. If these electrons go here, that charge goes away. because this now gets to share those electrons. But this is going to be, it's going to have 3 bonds and 1 lone pair of electrons, and that's a problem. Okay, so now I'm going to come here and go, let's take that and put it here. Nope, I don't want it. That's too close. And let's come over here and say these come here and grab that proton off of there. And that goes there. Okay. Better add a step. Boom. Over here. Boom. Boom. This is now gone. That's gone. That's gone. Another one pair of electrons on here. I don't think that we're going to be required to put that additional protonated or the chloride, right? I just lost the chloride. It's just gone because we only care about the organic product. I'm pretty sure I'm going to get credit for this. I do actually. You know what? I am going to have to say which side this went in on, because it's either going to come the top or the bottom, and it doesn't matter if I draw the hash or the wedge because the instructions give me the choice to do either. Let's go with the wedge. Right? Because all I'm doing is drawing the reaction for this product here, okay? So I think I've got everything I need. And I'm going to check it. That's a little fast, but hopefully that's helpful. A little fast, but also a long video. So hopefully that's helpful. Let me know if you want to see more instances of that. I do have some time tonight. Not a ton, I guess, but I'm interested in helping if I can. Good luck.